Hello, this is Jesse Walls, and today I'm going to be covering our Chapter 8, similar question to our question 20. Um, so, basically in our question 20, right, we're given two sets of data, and we're trying to figure out if they're correlated or not, like we've done before. But we're also going to be, comparing it to the Cohen, if I'm pronouncing that right. Yeah, the Cohen's d to measure the effect size of the study. So we're kind of applying both of what we've already done in the chapter, and then making one like bigger application of it. So to start, right, I have all of our variables written down. Turn that off real quick. Our alpha being 0.05, our m being 6.5, our mu being 7.0, our n being 16, and our sigma being 1. Ew, sorry. These are the two formulas we're going to be using. So let's get started. So let's start with our sigma m, and that'll be 1 over the square root of 16. So similar to 4, right, we're going to do 1 divided by 4, and that will be 0.25 is equal to sigma m. Then we'll do our, I don't like that. Then we'll do our z-score, which will be our mu of 7.0 minus our m, which will be 6.5. And then divide that by the value we found up here with our sigma m being 0.25. So do 0.25. So let me grab my calculator this one because I can't do this one in my head. So 7 minus 6.5, that'll be oh my goodness, yeah. If I can do it in my brain, just 0.5, yeah. 0.5, then we'll divide that by 0.25 divided by 0.5, and that'll equal 2. So now we'll use our alpha variable, which is 0.05, and we'll check in the back of the book 0.05 and find our df, which in this example we had 16, so 16 minus 1 is 15. We'll scroll down. We'll see that the variable we're trying to look for be 2.131, so it has to be 31. So our value here needs to be more extreme, both positive or negatively, than this value. So we got 2. So for this example, our answer is no. Does not break. No. Now, with the section B portion of the problem, right, we are asked to use the Cohen's D. Believe Cohen's. Yes, the Cohen's D to measure the effect size of the study. And so to do that, right, we're going to use a new formula, being m minus our mean over our sigma, which this will equal, make sure I use the right numbers, 6.5 minus 7, right? Yes, sorry to move it back and forth a lot, over our sigma 1. So it'll be easy. Make sure that's a big enough dot. So this will be negative 0.5 because you're just dividing over 1. So with our negative 0.5, it'll be of medium effect size, just because it is between the road of 0 to 1 negative. So there's a negative correlation. So as one thing rises, another falls. So in this case, right, we saw as an increase of the weather conditions, moderate compared to very hot, very cold. Basically, we see it as like weather increased, both negative or positive, and extreme, that there was a negative correlation to the effect of weather. So as one rose, the other fell. In this example, right, that's not correct to actual weather, but let's just look at it statistically, right? Let's say the hotter it gets, the more, the less extreme the weather is, because as one gets more extreme, the other gets not as extreme, would be what we basically see here. Um, so yeah, hope that helped you. And if you have any questions, feel free to reach out to either MK or I. Thank you very much.